on number 12. So in the study, whatever, blah, 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 we don't know the details. They're asking for n. So let's dive in. They're asking for n. And so if I'm going to write n, I'm going to write the n formula here. And so there's two cuts. So whenever you get an n question, in this section anyway, you need to figure out which table am I using. Is p hat not known or is p hat known? What does it say? Assume that nothing is known. See those words up there? Nothing is known. So I'm going to use the side that says p hat is not known. So that's going to be z squared times 0.25 over e squared. Good so far? And then what's the z? Oh yeah, I want to put this on the thing. What's it called? On the YouTube so everybody can have it. So I better do that, huh? So sorry, I'm going to use some time here to write this out so it's saved for y'all if you look back. So what was it? So p hat, 7.1, finding in p hat not known. And in that case, the n is z squared 0.25 over, it's an e down there, e squared. And then over here, p hat is known. If you know something about the sample standard deviation, or the sample proportion, then q hat is 1 minus p hat, and n is z squared times p hat times q hat over e squared. And then that table, so confidence interval, so 90%, oh, I don't have enough room here. So confidence interval, 90%, 95, 98, and 99. And the z values that go with them. What were those z values? It was there they are. So they're long. 1.644, 853, 626. And then the next one, 1.9. 599 9599 639 63986 2.326 347 877 2.5 75 829 303. Okay, so there they are. Same thing that's on the board. There it is. Let's go back over here and finish it up. So, okay, so what is my z value? What level? This is 99%, right? So if you go to the 99%, the z value is that bottom one. So I'll put it in there. Oh, it's going to be big. So what is that? 2? I don't know if I have room for all that. So it's going to be 2.575 829 303 squared times 0.25 over e. What's the error? Oh, it's right there. 0.04 margin of error. So that's 0.04 squared. All right, so hit the buttons on your calculator. You guys able to do that on your calculator? Notice this is squared here. And the bottom one is squared. The 0.25 is not. I'll do it too. Let's see what we're getting there. If it's a big number, put in your calculator there. I'm getting 1036.7. You getting that? And the thing I forgot to say, what do we always do for n values? Round them up. So we'll go up to 1037 on that. Let me write that over here. Always round in up. And by up, I mean even like 0.1 will go up. You guys tracking with me? Even 0.1 goes up. So always up. So 1037. So what does that mean? What did we just find out? That means you need to talk to 1,037 people if you want to get the information you want to get, which is what? Some financial aid, percentage of full-time students who earn their bachelor's degree in 4 years. Yeah. So if you want to find that out within a 0.04 error margin, you got to talk to 1,037 people. So that's what they do at the beginning of a study. That way they figure out how many people they need to talk to get the kind of accuracy that they want to get on the problem. Does that make sense? It's telling us how many people you need to survey to get the kind of accuracy you desire. How about part B? How's B going to be any different than A? Now, notice B, assume prior studies had shown that about 55% of the full-time students earn the degree. So they're giving me P hat. That's the other time, that's the second case when P hat is known. So let's do part B now. It's going to be, everything's going to be the same except we're going to have a P hat and a Q hat. So is it okay if I move off the screen there? You got that one down? So let's do P hat right here. Where is it? I just lost it. Oh, it's right down here. Yes, I need a fresh screen. So let's go there. So they're saying 55%. So that means P hat. And the hat means sample. That's a sample proportion. That's when they put that little, instead of just saying P, whenever they put a little hat on it in statistics, they always mean that came from a sample. So we don't know that's the real proportion of students who earn their bachelor's degree in 4 years. That's just, the 1,000, 2,000 we talked to, 55% of them earned their degree in 4 years. So it's distinguishing the true proportion from what our little sample proportion. Be like polling, right? So I polled and 55% of people are going to vote for candidate A. That doesn't mean it's going to really be 55% on election day. It means that's my little sample. That's what I think. But I'm not sure what the truth is yet. So the P hat is what we think. It's the sample proportion. And then you got to find Q hat. How do you find Q hat? 1 minus P hat. In other words, it's the opposite, huh? It's like if there's a 55% chance of rain, what's your chance it's not going to rain? 45, right? The Q hat will come out 0.45. It's just the opposite. P hat and Q hat are just the opposite. So Q hat's the opposite of P hat. Does that make sense? So they gave me P hat right here, 55%. Q hat, the formula says, is 1 minus P hat, which comes out 0.45. And now we stick them in that formula. So I'm going to get a fresh screen here. So on number 12, part B, they're telling me P hat is 0.55. So I calculate Q hat as 0.45. And then I write the formula. It's going to be Z squared times P hat times Q hat over E squared. So let's plug this stuff in. What is the Z? Same thing it was before. That big, long, crazy number. For, what was it, what percentage are we doing here? 99, right? Yeah, 99. 99%. We're still doing 99%. So 99% is that big, long, crazy number. 2.575, 829, 303 squared times P hat. 0.55 times Q hat. 0.45 over E squared. What was the error? 0.04. Squared, yeah, got to square it, huh? Exactly. And then hit the buttons. I'll do it with you. 0.575, 829, 303 squared. It's not going to come out much different, I don't think. Just a little different. I'm getting, yeah, not much. 1026.3. So what do we do with that number? What do we do with every n number? Up. Even the 0.3 goes up. 1027. Did y'all getting that? Is that coming out on your calculator okay? Yep. Questions on that one? Leonardo?
Just the 0.3, I'm just not tracking how it goes up.
Yeah, the reason for that is, so remember what we're doing. So it's not a math thing. I mean, it sort of is. It's a real life thing. So let's be real with this. What are we even doing here?
Making it into an even number type stuff, right?
There's more to it than that. What are we doing here? Like, what is this 1027? How about, let's make sure we're being real with this. What is that 1027? 1027 what? Amount of people we need to talk to. Right? So let me ask you, if you talk to more people, will that improve your accuracy or decrease your accuracy? More people means you're more sure, right? If I said, hey, I talked to 10 people out there and 6 of them are voting for candidate A, you go, whatever, 6 out of 10, who knows? It could have been just 10 wackos. If I said, no, I talked to 1,000 people and 600 of them, 60% are going to vote for candidate A. That's more believable, right? The more people you talk to, the more believable the results. Well, that's why we go up, right? It's rounding down because we want a certain amount of accuracy. And so that means if we could somehow talk to 1,026.3 people, somehow we could exactly do that, then we get exactly the accuracy we want. So therefore, if you rounded it down to 1026, you would be getting less accuracy than you want. So if you talk to more people, you're getting more accuracy. So the first amount of people that will give us the accuracy we want is 1027. That's where we go up. Good? Questions on that? That makes sense? You okay with that in formula? All right, so number 13. I better write out the important points, the salient points. 90% confidence interval.
Mr. Heron.
Yeah.
The part C, what is it?
Oh, was there a part C?
Yes.
I didn't even notice. Oh, I don't know. I never pay attention to those words. Let's see. Does the added knowledge in part B have much of an effect on the sample size? In other words, did the sample size answer change much? No. I mean, 1027, what was it before? 1037? I mean, it only changed by 10. So no, that didn't change it at all. So in other words, did knowing about what the sample answer is going to be, did that change very much how many people you need to talk to? No, hardly. Is that what it is? Using the additional survey information for part B only slightly reduces the sample. Yeah, it did reduce the sample size, but only slightly. Yeah, that's right. Yeah, good question. All right, so 13, we're doing a 90% confidence interval. Your operations manual for an manager for an airline and you are considering a higher fare level for passengers in aisle seats. You want to charge the aisle seat people more money. How many randomly selected air passengers? You want to see what percentage of people want aisle seats. Is that what you want when you're on an airplane, an aisle seat?
I like the one.
Assume that you want to be 90% confident that the sample percentage is within 1.5 percentage points. All right, so let me write that. Now I said, and you want to be within 1.5 percentage points. And then part A, assume that you know nothing. So you know nothing about p hat in part A. All right, so let's crank it out. Let's write the in formula. It's going to be z squared 0.25 e squared, right? We good? I'm grabbing the know nothing about p hat formula. And the z, what's this for 90%? So the z number is another big old long number, 1.644853626 squared times 0.25. Good so far? So here, everybody, because I want to show you what tricked me when I did this homework problem. So it might trick you as well. So what tricked me at first was not any of that stuff. That was all good. And then what should we put in for the E?
0.15.
Yeah, notice you got to move that decimal. You can't. I put in 0.15, 1.5 at first. It's 1.5 percentage. That's why they wrote the word, so they fooled me. If they would have put the symbol, I think I would have noticed. But they wrote the word. So what do you have to do when you change 1.5% to a decimal? 2 places, it's going to be 0.015. Does that make sense? You know that, like if somebody gave you 37%, you'd make it 0.37, right? You know, just the format, the fact that it already had a decimal, and I think that they wrote the word, I think those things just fooled me. And I forgot to move the decimal. Does that make sense? You have to move the decimal when it says percentage, by word or by symbol. Either way, you got to change it into a decimal. So 0.015, right? Goes back 2 places. That's why that symbol has 2 zeros in it. It's reminding you 2 places back, right? So put that in there. Hit the buttons on your calculator. I'm getting, 3006.1, blah, 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 which goes to 3007. Let me, is exactly what we need, those big numbers I gave you. Yep, that's right. 3007. So Math Excel won't hassle you. These will be the right answers. I was using shorter versions. Remember those shorter versions I gave you last time? I was using those, and I was getting answers that were off a little bit from Math Excel's answers. And I didn't figure you wanted Math Excel to tell you were wrong all the time in your homework. So, and I realized if I used more accuracy, it was right. So we have to use a bunch of digits. Anyway, we good there? Is that making sense? Part B, how about part B? They're going to keep doing the same thing on every one of these. Part A will be the you know nothing about p hat. And then part B, they'll give you p hat. You know, it's going to be the same thing on all these problems. So part B, they're saying now the survey says 35%. That's p hat. You see the drill? See what they're doing? They're going to do that every time on these in problems. They're giving me p hat is 35%. So part B, come on down. P hat is 0.35. So can you do it one more time? So P hat's 0.35.
65.
So then you got to grab Q hat. Right. If there's a 35% chance of rain, what's the chance it won't rain? 65%, right? It's 1 minus. So Q hat's 0.65. And then you plug it into the formula. Its N is going to be, what is it? It's going to be the Z. excuse me. Z hat squared times P hat times Q hat over E squared. And so what is that? Z, what's the Z? Same number it was a minute ago. 1.644853626 squared times P hat 0.35 times Q hat 0.65 over E. What was the error? Same error, 0.015 squared. And I'm getting 2735. 2735.6, which rounds to 2736. Anybody else getting that number? 2730. We always round up. More people is a more accurate study. We can't talk to part of a person, so we got to talk to one more whole person. 2736. Let me double check the answer. Questions on that one? We good with these ends? Okay, back to here. Got to add one to it. We'll put it up top. 1%, 1.28, 1.28, 155, 1567. Okay, so there it is. It's stored on the, where's the numbers? There it is right there. No more than 3%. So your error would be 0.03 on that one. 95% confidence interval. The rest is the same on that. So 14 is the same. I'll move on to 15. C. So A and B are the same. So there it is again. 7%. That'd be 0.07. That's the error. You want to be within that amount of error. That's how accurate they want the results. That's what they're saying. They want to do a study that is pinpoints something, whatever it may be. In this case, it's some toothpaste thing. How many adults must he survey to be? What is he trying to figure out? Oh, how many people recognize his brand of toothpaste? Whatever. He wants to figure out the percentage. He wants to be within 7% error. So that's how accurate he wants his statement to be. Does that make sense? So if he figures out that only 20% of the population recognizes the name of his toothpaste brand, White Bright or something, how many recognize that name? I'm just making things up here. And he wants to find out within 7%. So like, for example, if the real deal is 20%, he wants to go from 13% up to 27, right? 7 below it, 7 above it. That's what that error number means. You want to come up with an interval accurate so that it's off no more than 7%. You want to be, whatever it is, 95% confident that you're within 7% of the real percentage who recognize that name. That's what you're doing. Anyway, so part C, I'm sure you can, or part, C, whatever. What's the answer there, Nuruddin? Well, I guess it depends. So you got different numbers than we did.
No, the question was the same. It's B.
Is small. Could he simply survey the adults at the nearest college? No. A sample of students at the nearest college is a convenient sample, not a simple random sample. Yeah, totally. Yeah, when you do sampling, remember we talked about that in the beginning of the course, first week. You got to be careful how you do sampling. If you only talk to college students, that's a certain kind of people, right? That's different than the general population. Maybe college students watch more commercials or less commercials than other people. They might recognize brands more than the general population, right? Whenever you do surveys, you have to be general, right? If you want the truth, right? Remember we talked about the elections where they blew it, and they went and talked to rich people, and then they thought they knew who was going to vote, how the vote was going to go, and they blew it. Remember all that? That magazine closed down, all that? All right, we better move on.